We have assignments for this class, 6 of them, by the way. If you haven't turned them in, they're technically due Monday, 4/22. So, which is the due date for everything. And I have a lot of people still asking questions about them. I'm sorry? Midnight, I believe, on 4/22, which is 2 days from now. If you're an ITU student, that's the absolute deadline for you. Where are you going to get these fabulous assignments, which maybe some of you haven't seen yet? So if you haven't seen them yet, I don't think there's any hope for you, but you could spend your lunch break working on them and we'll see what happens. Spring 2013, object-oriented programming in Java, assignments. We went over the first couple of them the first couple weeks of class. We actually saw the swing one. We saw examples. So what I've got here is kind of the rundown. The ones that we've spent a lot of time on was 1 through 4. 5 and 6 I don't believe I've spent too much time on. So I'm going to go over number 5 for you. And number 5, is that, actually wait a minute, is number 5 the swing? Oh, it's the people. So let me just do something real quick here. Let me just save these guys here. I'll save them all to the desktop here, and then I can go over. Is there any? Okay, so what I'll do is I'll query the class to see who wants to go over each one of them. So when I mention the assignment name, raise your hand. Assignment number 1. Do you want to go over assignment number 1? Assignment number 2. Assignment number 3. Oh, okay, 3 is a good one. So let's talk about 3. It's kind of like an auction. Do I hear 3? Do I hear number 4? Let's see, number 3. By popular demand, assignment number 3. Stacks and queues. Stacks and queues. Do you remember the utilities? I'm actually going to be reviewing stacks and queues later today. But remember the utilities class where we have dynamic arrays, and we had arrays, we had containers. Inside of there we had a stack, and we actually had a queue, and I went over about 4 or 5 different examples of both. One of them held multiple different types of objects, and then I showed you how to use the object specification, so you can say this is integers, this is floats, this is doubles. If you missed any of that, I put together some videos for it, and I saved it actually, and the video links, if I remember this correctly, are still out here actually. This is number 3, the how-to video. All these examples are out on the website. Most people who have problems with this have problems because they're putting objects inside of the structure. And then as soon as you start going from an integer, from a float, to a person, or to a stock, then for some strange reason there's like a math block or something. There's like this really weird pencil block or something. It's all the same, however, though. It's done the same way. So what are you doing in here? You're going to make an object that's going to represent a stock. And the stock is going to be something that you're going to buy and sell. And you're going to keep an array of these stocks, or you're going to keep some structure that's going to hold the stocks. So companies and people often buy and sell stocks. Often they buy and sell the same stocks at different prices. Say a person owns 1,000 shares of a certain stock, such as a Checkpoint. That's just the name of a stock. You can make up your own stock. She may have bought the stock amounts in 100 shares over the last 10 times, maybe 10 different prices. So you're going to keep track of an object instance. So I'd make one stock, and you can use the same structure actually for both the queue and the stack. So you guys remember the stacks and the queues. The queue's kind of like the line at the grocery store, the bank. The stack is sort of like the plates in the cabinet, one on top of the other, or runtime environments. I covered all this stuff actually. So what you're going to do then is keep track of stock, an object, inside of one of these structures that you're going to put together. when you figure out which class you're supposed to inherit from, which container. And you can do it any way you want, actually, using any type of structure that you want from the utils package, or any package, actually. And you're going to have a little menu here, and the menu is going to have you enter in a stock and then find the first in, last out, or first in, first out price of a stock. The stock is going to have a couple data members associated with it. It's going to have a price, maybe a quantity, or maybe a name, something like that. So what are your general questions about this assignment? Why did you raise your hand? Yes?
So how I implemented, like I have created a class and I have three instance variables. One is stock price, name, number of shares.
Yeah.
And I'm adding those objects in array list.
Perfect.
So my question was, when you go further down and right there you say that press 1 to enter a new stock. If you do that, so those objects will be stored at the end of the an array list or at the beginning of an array list.
Okay, so you're having problems with the fundamentals of the differences between first in, first out, last in, first out. So if you're choosing a stack, you would be adding things to the same end that you were taking things away from. And it would either be at the top or the end, at the start or at the end. So the kind of the main concept differences, if you're going to use that stack concept, is that you're reading and writing to the same end. Or you're adding and removing from the same end. It doesn't really matter which end you're working with abstractly. On the queue, you're removing from one end, you're adding to the other end. You can create a stack, use it like a queue. Create a queue, use it like a stack. It's a concept, it's an abstract concept of how you're going to put something in and how you're going to take something out of the structure. So your implementation of it can be totally unique in terms of the concept. You can have one like array or one something, whatever you want to use, and just have different methods and have a hybrid and use them both together. Or you can create a separate one for this one and a separate one for that one over there.
I have one array list and I'm just storing all the objects in the array list.
Yeah.
And for the first in, first out, I'm just like once
the last item that was put in, yeah.
Once you enter the number of shares, like we have 5 objects in array list and you're
Yeah.
using just 2, so it will just take the beginning of 2 and calculate the value.
If it's taken the beginning of the list and you're adding to the end of the list, that would be correct. Because the first one in would be the first one out.
Yes. So that's what I wanted to
Yeah,
know.
that's perfect. That's perfect. And then the last one in is the first one out, which means I added one in, now I'm going to take one away. Which is actually how stock purchasing works, if you think about it. You know, you buy a piece of share of stock and you sell it, and you're kind of thinking, well, did I lose any money? Well, you just bought it. So what was that one you just bought, you know? And then you can kind of calculate on it. If you're going to do it that way, you can do it both ways. A lot of people just take their entire portfolio and say, over the last 5 years, I bought so many shares, and this is what I paid for all these shares. And what's the current price? You add it all up, divide it out, figure out what the average you paid for it was, and you know if you've made any money or not. Because on one stock you're going to lose, and on another stock you're going to gain. So you can balance it all out, which is what you're simulating here, essentially.
So essentially, whenever you're actually buying a stock, it's creating a node in a linked list, right?
If you want to use a linked list, yeah. I wouldn't use a linked list, though. I'd use one of these built-in utility data structures. Look at the containers. The second weekend, I put a video together on it as well. It's like 2 lines of code. In C++, you'd write a linked list, or use a template class, standard template library. In Java, just use one of these utils, the util package. In the utils package, you have all the stuff pre-made for you. Just make an instance of the object array list or something, or stack, or queue, or list. You can use a list for it. Depends on what level of implementation you want to do, how much work you want to do, what kind of functionality, what kind of control. They will all hold instances of the stock. You can call it a stack. You can just call it my list. You don't even have to call it a stack or a queue. You can make one. You can make multiple. So you got a lot of flexibility. Yeah.
I'm not sure if I understand what the logic would be for this. So you enter one
object.
Well,
You have an object that's representing a stock. And the stock has a name, a price, a quantity that you're going to put in the object. You can do one stock at a time. You can buy them in 100 stock increments if you wanted to. So if you had 200, you'd have 2 of them, 100 each.
Oh, okay. So you buy, if I enter quantity, or
If you want to simplify it, you can just buy one stock at a time. And each object would be equivalent to 1. So you bought 3 of 3 instances of the object. Or you can make them into 10s or 20s or 30s. It's like dollar bills or money. How many bills do you have? I have 3 bills. I don't know how many bills I actually have. I'm getting ready to go to lunch. So I actually only have 1 bill right now. I have a $20 bill. So I could take the 20 and turn it into 2 10s. And then I'd have 2 bills with the same amount. So if you want to make your program so you're buying the stock in increments of 10 or 100, you can do that if you want. But you have to keep track of the increment. You know, are they worth just 1? You have 10, 1, 15. So if I had increments of 1 and I wanted to buy 10, I have 10 objects now. If I have increments of 10 and I buy 1, I only have 1 object. So it depends on how you want to do it in terms of your abstraction. The assignment doesn't tell you anything outside it. You must keep track of the number. If I have 1 and I buy 3 and I sell 2, my calculations are going to be easier. If I have 1 and it only holds 10 and I don't buy 10, then I can't make 10. And if I sell 5 of the 10, then I got to break up the 10. You got half a 10, which is why I get 2 5s. I can't get a 10 back out of that, huh?
How do you calculate the cost? So I buy 3 and then I have to put a price.
I'd fix it so that you were buying in set increments to make your life easier. And then you're fixing the price. So if I'm buying this stuff in increments of 10, and I fix it, so every one of my stocks is going to be 10. And first one I bought, I paid $5 for it. And the second one I bought, I paid $10 for it. I have 2 different costs. They're going to be stored in the 2 different instances of the objects. And then if I sell 20, I'm going to sell both of those 2. And I know my cost was 5 plus 10, $15. And if I sold it at $30, I made $15 on the sale. If I only sold 1 of them and I sold the first one and I bought the first one at $5 and I sold the first one for $15, then I made $10 on the sale.
I thought we were just calculating the cost, not the profit.
Well, that's what I mean. You can do the cost the same way. You can do the entire portfolio. Let me read through the directions then. So say a person owns this amount of shares. You're going to analyze 2 different methods for accounting, and you're primarily concerned with the cost. I was talking about profit. Apply it to cost. So the information is typically calculated when a stock is sold. When you sell it, you're looking at the cost to see what kind of profit you're going to make, which is the same thing I was just telling you.
Let's say we buy, it includes 10, we buy 30 shares.
If I made an instance of an object right now, because the price right now is $10, I'd assign $10 to that object and say, here's the object. I bought 10 shares for $10. Object number 1. 2 days from now, I say, I want to buy another one. So I create object number 2. Now the price is $20, and I'm still getting 10 shares. So then when I create the instance of object number 2, I set that price at $20. And then I put both of those 2 inside of a structure. And if I want to sell 2 of those out of that structure, I only have 2, so I can only sell 2 at this point. If I put 10 of them in there and sell the first 2, I'm going to get a different calculation for my cost than if I sold the last 2. If the cost is going up. Yeah. Which is how you're doing it. It's accounting in terms of, when did you stick it in? When did you buy it? When did you sell it? Kind of thing. Any other questions on this one? No? We're good? Okay. Item number 4. Assignment 4. Any questions on assignment number 4? Yeah. Okay. Number 5? Oh, number 5. I think I'm trying to download number 5, but it's not working. Let's take a look again here. I probably have it downloaded somewhere. Let me just close this guy out here. Maybe that's the problem. And number 5. Save number 5. Unknown time remaining. Am I not having I have an internet connection.
Can you go to number 4 also?
Okay, number 4. Number 5's going down here. I don't know why I can't get number 4. Or excuse me, number 5's not working. Number 4's not working either. Maybe I have these downloaded. Let's see. No, not in here. I had them downloaded and I may have... Oh, here we go. Number 5? Number 5 it is. We'll go back to 4. But I have number 5 right here. Number 5 is the person, the employee, the student, and the instructor. And let me open this up so I can make it a little bit bigger for you. This one, the trick with this one is the array of objects, and you have to do an is-a relationship and cast them all down to people if you're going to store them all together. So here's how you do it. We've got ITU wants you to keep track of the personnel records. And we're going to make it simpler. We're going to have 4 classes. We're going to have a person, an employee, an instructor, and a student. Person is the base objects. And then we have an employee. Employee can be we can have students who are employees. We can have instructors who are employees. Or we can have just this line here. I think we have I don't think we have the entire line complete. So the following are tasks. So what we're going to do then here is we're going to create a bunch of these items. We're going to assign them all data members and member functions. They're all going to be taking care of their own stuff. And students are going to have teachers. Teachers are going to have students. So instead of them being, a student doesn't come from a teacher doesn't come from a student. Instructors aren't students, but instructors are employees. Students aren't employees, but students are people. So we have the is a relationship going on between the items. So eventually we can stick all these people, we can stick the students and the instructors all in one array if we want, and then we can check through the array and see which ones of you are students and which ones of you are teachers, and assign students to teachers and teachers to students. I actually did it for you. I put that part of it in the video that's out here that appears to be unavailable right now. I'm not quite sure why. Let's take a look here. I got internet access, so maybe my website's having a problem. I'm not sure what's going on. Yeah. Is this number 3? No. This is number 4. No. This is number 5 I'm going over. Yes, number 5 has the sample output and has a test program to it, and it has a video. In this video, I do most of it for you. So there's an array of students inside of each one of the instructors, and then there's an array of instructors that can be, I believe, inside of each one of the students. One of them's optional, actually. It's the same thing done in the reverse. So you cast them all the people, and you figure out which ones of them are students, and you can print out who their teachers are. And then you, if all the objects are in the same array, then you can figure out, well, which teachers have which students and which students have which teachers. And you can set the maximum to 10, I believe, in the assignment. So each student has 10 teachers, or each instructor has 10 students, or something like that. You can assign them, and then the objects themselves keep track of that information. So what was your question? Or whoever wanted me to go over the number 5? Do we have individual questions? Yes.
Can you show the UML diagram for this document? The time when I downloaded the assignment, there was a diagram which showed the...
Yeah, it will actually show up if I bring this up in Microsoft Word, which I don't have on this computer.
I was doing according to that diagram, but...
Yeah, the diagram looks like this here, actually. I think we have a person, or maybe I can... I don't recognize the word. Let me see if I can put it in here. Actually, let's see if I can make a makeshift diagram here. Text Wrangler. Let's do it in Text Wrangler. Yeah, it's has person on the bottom, and then, or excuse me, on the top, and then we have an employee. Imagine some lines being drawn here, and then we have a person's also a student. So we have student here, and then employee. Underneath employee, we have instructor, which is also an employee. I did this actually in class, in week 2 or actually maybe week 1 actually. Week 1. The first weekend we did this. There's a video on that. And then there's this other one that I put together that writes this all out for you, does the inheritance for you. But if you download this and you open this file up, see those really weird characters up there? There's a UML diagram that will show up if you're bringing up Microsoft Word. It's not going to show up in here because this is preview and it doesn't format correctly. But it's a very simple diagram actually that resembles, if you draw some lines in here, there's like a little triangle kind of thing going on here. Then we have one line going down this way for instructor. If we had another, if I wanted to, let's see, let's go up this way a little bit here. I could have a staff, and also employee, different types of employees, and then maybe instructor. Maybe there was just one line going down between employee and instructor, and then under this one I can put here grad or undergrad. You know, instructors that teach grad classes or undergrad classes. Or I could have grad and undergrad students if I wanted to make the hierarchy bigger. Don't necessarily need to do that for the assignments. Other questions on assignments? Yeah?
Student?
Yeah?
And then I watched the video.
Oh, you did? Okay, yeah.
The last version that they say you have to find teacher, I think.
I don't know if that's really part of the assignment description though. Is it? Oh, that's the interesting thing. So when I started doing it, I was working off my memory of it, and I think I added more to it than needed to be there. But let me just review the assignment real quick here. So consider only 4 classes here. Let's see. All the above fields are private to string methods. So there was a find students. So a static find students method. So it's a class level method. And they're going to run in main. In the instructor class, so you put it in the instructor class, and this finds the instructor's object students in the ID array. And then corresponding students, so it is both in here. So the students find the teacher's ID fields. See the test program for better understanding. It's the same method, it's just done in the opposite order. So the one inside of the teachers finds the students, the one inside of the students finds the teachers. But you can get it both ways by going to each one of them. In the video, I think I have the teachers find the students, or
The instructor finds the student.
the instructor finds the students. Yeah.
And then, so that means I need to set a private integer for student ID in student.
In student, yeah, students have student IDs. So when you go through the array to check, it looks at the student. It looks at the object and says, is the object a student? If it's a student, look for the student ID.
Student just have just teacher ID, not the student ID.
Yeah.
Okay. So you could add it if you're going to do it both directions. You can add it. Yeah, you would have to put a student ID inside of the student, and a teacher ID inside of the teacher.
Because the test class you have given that has mentioned the student ID.
Yeah.
And in the diagram it wasn't there.
Oh, okay.
So it was given.
If you do one of them, that's enough.
So,
If you do both, then you're exceeding expectations. Yeah.
then there was another called teacher array, right?
Yeah.
Student array and teacher array.
Yeah. If you did both of them. If you do it once, that's enough. Because isn't it the same thing? You're just doing it the opposite direction. So I was just looking to see if you could figure out how to do something like that. So. And also the grading on this is not whether it compiles or not. It's do you understand the concept? I'm not even going to compile your stuff, so don't give me the .class files. Give me the .java files. It's okay if you give me the .java. It's okay. If you give me both, that's better actually, but you don't have to. So when you upload or you email or you do anything, just the .java. Don't put it in a Word file. Don't cut and paste and put them all in a Word file. That doesn't make any sense. Zip them all up together, all the .java files, and post those. And then when you're doing that, I'm not going to like download everybody's .javas and look at. I mean, I'm going to look at them. And I look at the methods to see if you're making logical sense. So the criteria is, did you do it yourself, or does it match identically to somebody else's program? That's strike number one. And strike number, if you did it yourself, are you doing the assignment? You're doing so. Okay. Do you understand the concept? Are you doing something legal? legal Java syntax? Does it look like you wrote it? It's primarily on effort in terms of your individual learning objectives. Obviously, there's different ways of doing it. And I spent all morning telling you about how something should be private and something else should be public, and how this should be an interface, that should be an abstract. I don't care about any of those stuff. You don't have to put Java docs in there either. Just make it work. But try to use good practices, because when you get into the real world, they're going to laugh at you. If you're doing something that's, if everything's public all the time, nothing is private, people are going to laugh at you. Where did you learn Java? So this doesn't make any sense. People are going to think you're an idiot, so. They might think that anyway, but anyway, just kidding. This is the main program, the test program. If you don't like the test program, you can modify it. If you like the program, leave it as is. If it doesn't meet your needs, change it. So, one of these has the same guy, Peter. He's a student and a teacher. So you can't use the name, so you have to use an ID or something. Because how do you know Peter or Bob or whatever is a student or a teacher? They both have the same name. So. Any other questions on number 5? Back at the ranch, I have number 4. That's the one I've been trying to download, I think. Is it? No. What was the other one? 6? Did we skip one? It was 4 I was trying to download. I might have to figure out what's going on with the download. Ah, no, here we go. 6 just downloaded. Maybe I have to try 4 again. Let's see. So let's take a look at 6. Oh, here's 6. I have 6 in here. Oh, 6 is not even a program. Don't worry about 6. 6 is a nice review if you haven't done it yet for the fun. Actually, 6 is not a program, but it's. Let me take a look here. Bring it up in preview. Sure. Let me take a look here. Get a little bit bigger so you can see it in the back. Answer a bunch of questions. I answered this one for you earlier today. Let's see. Number 3, part number 3, miscellaneous Java concept. You can actually cut and paste this. It's compilable code, as long as you get the formatting correct. What will the output of the following program be? Explain why. And then we have the weather. Problem 2. Last one I think is a UML refrigerator. Okay. The last question is what you want to question. Okay, good. So identify the classes of the following description of a refrigerator. List at least one responsibility for each one of the classes. You do not need to create the classes in Java. No writing of any source code. You can write little boxes. You don't have to do this in perfect UML either. But it's trying to get at your ability to describe how you would implement this by thinking abstractly about it. Just describe in words, or any way that you want, what set of classes you're going to create. Okay, so you have a refrigerator. I'm just going to work with the first couple sentences because I don't want to do the whole thing for you. But you have a refrigerator. A refrigerator has a motor. So the motor is probably going to be inside of the refrigerator class. It's going to maybe a subclass. Or excuse me, it could be a subclass. But it's probably going to be inside a nested class inside of the refrigerator. Because is the motor going to be able to use outside of the refrigerator? Probably not. It's probably going to, inside the refrigerator, you're going to have a motor. A class inside of a class. Okay. Probably going to be private. Can other people use the refrigerator's motor? No. Okay, you're going to have a temperature sensor. Probably going to be a method, yeah. So refrigerator, if you draw a box and put refrigerator in there and draw another box inside the refrigerator, call it motor. If you want to do this in a picture, or you can describe this in words. So then I have a temperature sensor. What's going to have a temperature sensor? Probably not the motor, but the refrigerator. So inside a refrigerator, I'm going to have a method that's going to be able to test the temperature. Maybe work with a sensor. Does a sensor inside the refrigerator? Probably. Same thing with the motor. Have some sort of a sensor in there too. And then a light and a door. Probably also part of the refrigerator. So we got a lot of nested classes inside of classes. Is anybody outside of the refrigerator going to be able to use the door? No, but probably going to have an open door, closed door kind of method going on. So you can add stuff like open door, closed door, turn light on, turn light off. Those are going to be messages that are going to be inside of this door, or excuse me, refrigerator. So the motor turns on and off primarily as prescribed by the temperature sensor. So the temperature sensor needs to communicate with the motor. Or needs to communicate with the mechanism. You can add stuff to this as well. You can have a controller in there. The controller could control the motor and the sensors. Read the sensor, control the motor on and off. You can draw this out like a picture. You can describe it like I'm describing it right now. I'm going to stop because I'm going to end up giving you the whole answer soon. But that's sort of like what I was expecting for that. Is kind of an abstract thinking concept where you're either typing it out or making a picture about how, if you were going to write this in Java, how would you assemble it without writing it?
Can we do refrigerator as an interface and then?
Oh, yeah, you can do that if you want. You can have some abstract stuff. You can have a refrigerator interface. Because, you know, think about how many different refrigerators are out there. Don't they all do the same thing? Keep food. Well, no, actually, I shouldn't say, because some of them are refrigerator freezer combos, and some of them are sub-zeros and stuff. You know, have different types of refrigerators. But if you think about the concept of it, you could make an interface, call it refrigerator, and then extend the interface by this hardware component you're going to call a refrigerator. And everybody who extends it does refrigeration. So you could have one that's a refrigerator and a freezer combo. Implements both the refrigerator and the freezer interface abstractly. So think out of the box, think abstractly. Use anything you want. Describe it in Java, like using the stuff that we've been talking about. It's way of kind of making it into a real life kind of scenario. If you were writing this program in Java, how would you design it? Any other questions on number 6? I think this is number 6. Number 6, yeah. What was the other one, number 4, that I can't get to? Why can't I get to number 4? Here's number 4. Oh, number 4, we went over about 7 different ways of doing number 4. Number 4 is that AWT notepad. I gave you like 7 or 8 different notepads. We spent way too much time on this one last time. If you have questions about number 4, it means you did not show up last weekend, or the last weekend we had class. You missed it completely. And if you missed it completely, go online. It's all recorded. Any other questions on number 4? I think it's lunchtime then. Yeah. It's already noon. It's already 12 o'clock noon. My stomach's growling. So I think it's lunchtime. And do we have any other questions before we break for lunch? No? Okay, good. So how long do we want to, let me stop this. How long